what exactly does the exponent represent? The exponent just represents repeated multiplication. So if you have b to the power of 7, that means you have b being multiplied to itself 7 times. Now, each time you're trying to simplify something that has an exponent, it doesn't make sense to write out, b 7 times or a to the power 5 times. So we have certain properties that help us simplify, like terms that have these exponents. So let's look at some examples of those. So firstly, exponents distribute. So if you have these two terms being multiplied, you can distribute your exponent to all the terms being multiplied. And this is also true in the case of division. Okay, so the n gets distributed. Okay. Okay, it seems like I skipped a slide. Yeah. Okay, here we are. So these are the properties in for exponents. The first one is product rule. You have the same base number, but they have different exponents and they're being multiplied. Then you can add the exponent. If you have the same base being divided, then the exponents can be subtracted. Any number to the power of 0 is always going to equal 1. Any power that has a negative exponent, you end up with the reciprocal. So here it's b to the negative m. I get 1 over b to the power of m. So let's say we had it this way. We had a to the negative m. That's basically a to the power of m. If you think about fractions, okay, so we have this fraction. Essentially, if something is negative in the numerator, it's going to become positive when it goes into the denominator. If the exponent is negative in the numerator and you move it to the denominator, it becomes positive. So, and then b has a negative exponent in the denominator, so if I move it up to the numerator, now it's positive. So that's how negative exponents work. And then finally, we have power rules. If I have b to some power and then I have another power outside, then they multiply. And then we just spoke about the distributive property. So now let's apply these rules to these examples. So we have base 3 and they're being multiplied and they have different exponents. So I can add their exponents. So I'm going to have 2 plus 3, so 3 to the power 5. Now what if I have something like this? Well, let's use the commutative property of multiplication, because notice everything here is being multiplied. We have 4 times x3 times y4 times 10 times x squared times y6. So that's using a commutative property. We can move like terms around, or the same type of term can be multiplied. So let's bring the 4 and the 10 next to each other. Let's bring the x and the x squared next to each other, and then y4, the y6. And so we can associate these to each other. And then let's just apply the addition property or product rule. Well, 4 times 10 is just 40. Here we have x cubed and x squared, so those can be added to x to the power of 5. Here we have y4 and y6, so those can be added. We're going to end up with y to the power of 10. Now let's see how quotient multiplies. This is negative 3 to the power 6, and in the denominator we have negative 3 to the power 3. So notice the exponent is not negative. It's just the number itself is negative. The parentheses indicate that it's negative 3 that has that power. So since the base number is 3, -3, we can subtract and we get 6 minus 3. So it's -3 cubed, which will give you -27. Okay, now what if we have something a bit more complex? I would recommend in this case, write them out as multiple fractions. Notice because everything in the numerator, everything in the denominator is being multiplied. You can split this into 3 fractions. Okay. So now for this first fraction, we basically have 27 divided by 3. That's 39. The second fraction, you have x to the power of 14 divided by x to the power of 3. So you have to subtract the exponents. Now we have y to the power of 8 minus y to the power of 5. So now we just simplify. That's what we have. Okay, well, what did we say about the 0 exponent is it will equal 1. However, notice that the number 1039 is not in parentheses. Or the negative is not in parentheses. So this means the negative is separate from the number, and the exponent is only being applied to 1039. So we end up with, essentially we have this. So this number becomes 1. We end up with negative times +1, which is -1. So what happens here? Well, everything inside the parentheses, it doesn't matter how complicated it is. Outside we have a power of 0, so we're left with 1. Now, if you remember with the exponent rule, if something has a negative exponent denominator, it moves up to the numerator. And since there's nothing left in the denominator anymore, you essentially have a 1 down there. So 4 squared is 16. Okay, here we have x to the -6. So if I want to write this in positive exponents, well, the parts that are positive would stay like this. And then the x, that's negative exponent, would be 1 over x to the power 6. So this overall becomes the fraction y 3 to the power 3y4 divided by x to the power 6. Now let's apply the power rule. Power rule says you can multiply these powers because you have an inner power and an outer power. So 3 times 2, that gives us 3 to the power 6. Here, we have this inner power. The inner power is -3 multiplied to -4. So that gives us 12, positive 12. Now let's look at the distribution of powers. This power of 3 will get distributed to all of these. So we're going to end up with -2 cubed x cubed y cubed. Well, -2 cubed would be -8. And so then we have this. Okay. Even with division, this outer power gets distributed to each part of the numerator and the denominator. So we have x to the power of 5 times 3, which is 15, divided by 3 to the power of 3.